Project 17 was the synthesis of 4 different soaps and 2 different detergents. The goals of the project were to make 4 different alternative syntheses for soaps compared to lard and 2 different methods for making detergent so that they would be more environmentally friendly for an environmentalist group that was trying to clean up a spill, and this was done through testing the environmental impacts of the different soaps and detergents, running several qualitative and quantitative tests.
Some background on the project. Soaps are made by a process called hydrolysis, and that's when an ester is treated with water that is either acidic or basic, and then if a basic solution is used, it's called a soap, and the process is called saponification. And soaps and detergents both have a hydrophobic end and a hydrophilic end, and the way that they actually clean is any dirt or grease that's present in the solution is bound to or grabbed by the hydrophobic end of the soap, and the hydrophilic end kind of creates a bubble around it, and whenever water is used to wash it out, the hydrophilic heads want to go with the water, so the water just pulls that bubble out. So week 1 experimental design. So in week 1 we synthesized the detergents and the soap. We were assigned method 2 with the detergent, and we were assigned to use vegetable fat for the soap, and we used vegetable shortening, 6 more sodium hydroxide and glycerol, and then we heated it until a paste formed for the soap, and then added sodium chloride to make the soap more solid, and then we filtered out the remaining liquid. And then the detergent, we just combined sulfuric acid in 6 molar sodium hydroxide and cooled it in an ice bath, and then filtered it out to get the detergent solid form. For week 2, we tested the pH of the filtrates of all 4 soaps and the 2 detergents that we had, as well as the solubility of the bases for the soaps, such as the olive oil and the vegetable shortening. And then we checked the solubility of each soap and detergent in water, and then the oil dispersion of each. And then we performed a lather test for each soap and detergent and tested the cleansing properties of each. And then we titrated each of the filtrates until the pH plateaued, but in between either it being acidic or basic to start and the opposite to end, there was an area of neutralization that we used to perform calculations later. And then week 3, we checked the pH of well water and pond water, and then we tested the soaps and detergents in the pond and well water to test to see if a scum would form. And then we performed ion tests to test for cations and anions as polluters in the water, and then based on what was in the water, we either performed a neutralization or a precipitation to clarify the water, and then we tested the soaps in the pond and well water to determine if scum still formed.
So for the first test, we just tested the pH of the wastewater samples. So we got that all of the samples were basic except for method 2 detergent. So that's what we got for the pH.
Okay, for the solubility test, we found that they were non-soluble in water, but soluble in acetone and toluene, just because those two were nonpolar, and oils are nonpolar and light dissolves light. Also, something to note is that they're partially soluble just because they show signs of solubility, but just because of their solid nature, it was hard to dissolve. So with more time, it would definitely be soluble. And then for the actual soaps and detergents, we found that they were all soluble in water, and all of the soaps were basic and the detergents were acidic.
For the lather test, we basically just saw if any of the samples created bubbles when we added them with water and rubbed our hands together. So the biggest bubbles were formed by olive oil, and the method 2 detergent had the least bubbles, like there wasn't many at all. And kind of the reasoning for that is just because the opposite ends of the soaps come together with the water, and it forms a film of water which creates a little air bubble.
So the cleansing properties of each of the different samples, we found that the the vegetable fat was a soap alternative that stuck to the vial the most, which means that the hydrophobic ends would cling to the dirt more, or the oil or whatever you're trying to clean, making it the one that was the most effective in cleaning up the oil spill. And then for the detergents, it was method 2 that clung to the vial the most. So we figured that since it clung to the vial the most, it was the hydrophobic ends they would have had more of a connection, or would have like bonded or clung to the dirt more than the hydrophobic ends in detergent 2.
In the dispersion test, all of the samples, essentially when oil was added, it just sat on top of our soap samples. This makes sense with the previous results having to do with oil being added to water and it being nonpolar.
For the titrations, we performed a titration for each of the 4 soaps and each of the 2 detergents, and based on how many drops it took to get to a neutralization point, we calculated the concentration of each of the titrates, and we found that of all of them, the soap with the vegetable fat had the lowest concentration of the actual soap in the titrate, and then method 2 had the lower concentration between the 2 detergents of the soap in the titrate.
Our choice of which was the best soap and which was the best detergent was that vegetable fat was the best choice for the alternative soap production method, and that method 2 for making detergent synthesis was the best. And we came to this conclusion because they each exhibited the least amount of change in pH of the water samples that were tested. And for vegetable fat, it was the most soluble of all the soaps. It was at least partially soluble, so that meant that it would not stay in the water and pollute it. And then for the detergent, method 2 formed more bubbles than method 1, which means it had a better latherability, which helps with its ability to clean. And vegetable fat had the lowest concentration of all of the soaps, that like its wastewater had the lowest concentration. And then both vegetable fat and method 2 detergent had the better cleansing properties of the soaps and detergents.
So what is latherability? Latherability essentially is the ability for a soap or detergent to form bubbles when agitated.
And the soaps and detergents exhibit lather so what happens is the hydrophobic ends are trying to get away from the water particles, so they cling to the air molecules around them, and then they basically balloon up and form the bubbles that you're seeing.
And then the difference between the titration curves for an acidic versus a basic sample was the fact that if you had a sample that began basic, the curve started up at the top, and then as you added the acid to it, it slowly started to go down and then plateaued down towards around a pH of about 2. And it was the opposite for a solution that was basic, because it started very acidic, and then as you added a basic solution to it, the curve went up and then plateaued at about a pH of 10.
And finally, the scientific basis for the anion test. We did this when we were testing for contaminants in the wastewater. So, for example, when we did the chloride ions, we added silver nitrate to it because the silver nitrate's gonna create an insoluble product with the chloride that would be present in the wastewater, and that's gonna be like a precipitation displacement reaction.